You are listening to Demystifying Organizations. In partnership with McGraw-Hill Education, I'm your host, Jeff Shatton. My guest today is Jennifer Logg. Jennifer is an assistant professor of management at Georgetown University's McDonough School of Business. Prior to joining Georgetown, she was a Post-Doctoral Fellow at Harvard University. Logg's research examined how people expect algorithmic and human judgment to differ. In this podcast, we discussed a wide range of issues surrounding algorithms and decision-making. You'll notice that we do not bring up the coronavirus. That's simply because this discussion occurred back in January, before the coronavirus was top of mind. I'd like to welcome to the podcast Jen Logg. Jen, thanks for joining me.
Thank you so much for having me.
So it's an assumption that customers just don't like algorithms, and we seem to assume across the board that people who are on the internet, people who are on Google and Facebook, that they have a phobia of algorithms, and you seem to take odds to this. Why do you think that people are not so averse to algorithms?
Yeah, that's a great question, especially when so many different companies are kind of making this assumption. You can see it in the way that they market their goods or that they structure how they provide information to their employees. I think one of the reasons why people might be open to algorithmic advice is our default is to get advice from other people. And so there's this new source of information. And I think really it comes down to people are just more open to accepting it than organizations might assume in the first place. I do have data that suggests the higher people are in numeracy, so the higher their comfort with numbers, the more likely they are to listen to algorithmic advice. But over and over again, I'm finding that lay people are quite happy to listen to algorithmic advice when they receive it.
Can you give some examples of algorithms giving people advice that we see out there?
Sure. So you can think of mostly any recommendation you might receive. So something like Spotify or Netflix or Stitch Fix is normally an example I talk about. They are a company that provides clothing recommendations to their customers. So have you heard of it?
Yeah, I have.
So that business model has kind of proliferated throughout lots of different domains, not just fashion. But you basically, as a customer, sign up to receive clothes online without knowing anything about what they'll send. Mm-hmm. And they frame their whole service as a personal stylist who is providing you with recommendations. Every shipment you receive from them includes a note from your personal stylist. But the algorithmic advice is really driving the recommendations that people receive.
So is there a person at all behind that, or is it entirely an algorithm?
There is. It's a mix of algorithmic and human judgment. But really, before any person ever gets involved in the process, there's been multiple algorithms involved in narrowing down the consideration set of what the company might send to people.
So ultimately, will people be out of that process?
That's not clear to me. I think that's a really interesting question, and it deserves more attention in the research literature. I think more and more across the board, from things like recommending clothes to music to trying to figure out different decisions within organizations, there's always going to be room for humans to utilize algorithms as tools to the extent that humans will be phased out. I think that gets overblown a little bit.
Yeah, but I want to get back to this clothing recommendation thing. So if what you're saying is, so let's just, if I throw out a number, just tell me if this is off. So 80% of the recommendation is coming from an algorithm, and maybe 20% from the final human. Is that the?
Sure, that seems reasonable from what I know.
Okay, and then they're pitching it as this is a human to human interaction.
they play up the focus on the human side for their anything that's customer facing. So they actually have a hidden website that's called, I'm actually forgetting the name right now, but they have a separate website that's directed towards people they might be hiring. And there they highlight their algorithms as being hard at work and kind of the nuances of the different types of algorithms that they use. But that's completely separate. You can't get to it from their consumer-facing website.
So is this a human touch thing? And what I mean is, when we think of clothing and the emotionality that goes behind, for many people, certainly not me, I don't care about clothes, but for a lot of people, they really do care about what they wear, and if their friends recommend something or say that this looks nice or looks ugly on them. I mean, it's a high emotional state, as opposed to, if you think of maybe a stock pick, might be something someone's more neutral about. So do we know if there's a higher emotional valence, are people less susceptible or less open to an algorithm? Is that what the company's thinking, right? I can imagine
that's what the companies are thinking, yeah.
That like historically, we've always driven clothes, and clothing discussions have just been human to human. So why not create a product where it looks like it's a human?
That's a nice way to put it. I've always thought of it as on a spectrum of including emotion or not. I hadn't thought of it that way, actually. I'd been thinking of it as kind of more subjective domains versus objective domains. And so I have a lot of data where I've tried to test if subjectivity is a factor that moderates my results of what I find algorithm appreciation, people relying more on the same exact advice when they think it comes from an algorithm than if they think that same advice comes from a person. And so when I run kind of scenario-based studies to look at subjectivity, objectivity, I do find that people want a match of, if the domain is more subjective, so things like clothes and more communication-based between people, then they prefer advice from a person than an algorithm. But when I actually use a paradigm where I can explicitly measure how people are actually updating to numeric information as provided to them as advice, there I don't find this moderation by the domain. So you can think of, it's interesting, in the real world dating apps, you could say that's full of emotion.
Right.
And people are quite happy to have the algorithm give them recommendations on a lot of these apps.
Yes, that's how my wife and I met, which was on OkCupid, and they do these daily or even weekly emails that you get with recommendations, and they don't pretend to be handpicked. So
Right.
So they have no qualms saying that this is entirely just part of the program, and the bot is going to put out whatever the recommendation is. So are people? So and you're right. I mean, that's in a high emotional state. So how do people respond? Are you finding in your data to algorithms making recommendations versus that coming from a person?
Yeah, so I started off in a really objective domain, asking people to make geopolitical predictions about events that may or may not occur. They make a time one estimate, it's a numeric estimate, and then they receive advice that's numeric. And I give everyone the same advice, and it comes from past participants. So I'm not lying to participants, so I can avoid that. Economists are happy about that. So they see identical advice. I get an average of about 400 past participants' responses, which, based on wisdom or crowds, tends to be a pretty accurate piece of advice. And then my participants have the opportunity, after seeing this advice and seeing that it either comes from a person or algorithm, how much they want to update their initial estimate. And so when it
comes from a person, so they're told to make some prediction about a future event, and then they're given advice. And so some groups it comes from a person, some from an algorithm. Then they're going to maybe update their prediction. When it comes from a person, does it say it comes from a person or from the wisdom of crowds?
And it varies by study. So I wanted to make sure that the results would generalize. So in some participants see that it comes from a person. Other participants see that it comes from a lot of past participants, 400 past participants.
Okay.
And over again, when people see the advice and they think comes from an algorithm, they update much more to it than when they think it comes from a person or a group of people. And so I start in a really objective domain, but I even find these results when I say, here's a biography of Julia. We are trying to understand how people think about interpersonal relationships and meeting people. Now you're going to see a picture of Mike. Tell us how you think Julia would view Mike. How funny do you think she would find him? How enjoyable would she find a dinner date with Mike? And even there, when people are making estimates about, interpersonal relationships or person perception, they're still relying more on the same advice when they think it comes from an algorithm.
That's really interesting. And I think it's also, there's a troubling aspect as well, because algorithms are a black box, whereas a wisdom of crowds is not, right? So if I were to throw these three different categories, right, they're fundamentally different. So one would be a piece of information. Person X, who you've never met, says that the chance of going to a war with Iran is 25%, right? So we should certainly discount that if it's just some random person. We polled 1,000 people, and they said that there's a 40% chance that we're going to go to war with Iran. We should take that very seriously, right? Because if 1,000 people are making some prediction, right, that's going to get rid of the outliers, and that's right. That's backed up by data. That if you get that many people making predictions, we should take that seriously. That's why markets are pretty efficient. And then the third one would be some algorithm predicts that there's a 50% chance that we go to war with Iran. We know nothing about the algorithm, right? I mean, and all you say is that it's an algorithm, and I think we should be deeply skeptical if it's just blanket, just said there's some algorithm out there that has made this prediction.
Agreed. Yeah. So I wanted to test how people might be interacting with algorithms in the real world. And I thought most of the algorithms we interact with, Pandora, Spotify, Stitch Fix, are black box. We have no idea kind of what goes into them. So I had the same thinking. And so it is kind of surprising, with little to no information about the algorithm, people are actually quite happy to update to it. There is a lot of research in the area of advice taking that people are pretty insensitive to how many data points they're given. So they mostly treat advice from, I'm kind of generalizing here, but if someone gets advice from one other person, they respond to it similarly to if they received advice from the wisdom of the crowd. So they don't actually update as much as they should when they're getting this crowd wisdom.
Yeah. So are you familiar with AIEQ? It's a ticker. It's an AI trading algorithm.
No, I'm not actually. I feel like I should be Googling.
So no, it's fine. So there's an entirely automated AI ETF, and it takes in, I think it's something like 5-6 million data points a day, and is actively trading on in the stock market. And you can get an ETF with a very low expense ratio. And it has way underperformed the S&P 500. And it's been long enough now that you can see I think it's been around for like 2 years now. And so basically this machine algorithm cannot possibly keep up with passive indexes. And so what I take this as, it's interesting that there are areas, and I think the S&P 500 is one of them, that the best thing you can possibly do is just be lazy. And just, right, that the wisdom of crowds, it's tough to beat the wisdom of crowds. And the S&P 500 is the ultimate wisdom of crowds. And these AI systems are still struggling. I'm not saying that they will never at any point be able to beat the S&P 500, but my money going forward will continue to be on the S&P 500.
Yeah, that's interesting. That's actually kind of how I got into researching this whole topic. I was on a grant funded by IARPA, the Good Judgement Project, and they were basically, the goal of this grant was to try to take the wisdom of the crowds and figure out which algorithms could best aggregate that information. So combine algorithmic machine learning with the wisdom of crowds to figure out how to get the best, most accurate geopolitical predictions. And I kind of started thinking, well, our universities are working on this problem. It's supposed to, in the end, get sent to the CIA. Why do we think the CIA is going to listen to our algorithms? And so that's kind of what sparked the idea of, how do people respond to algorithmic versus human judgment? And so
do they? Do the experts take into consideration the algorithms and what they put out?
So eventually I was able to collect data from people who, national security professionals, so people who make forecasts on a daily basis and are paid to do so. And I compared their responses to the same exact predictions, very simple judgment tasks to geopolitical forecasts with lay people. And the lay people, again, were showing algorithm appreciation, updating much more to advice when it came from an algorithm than a person. But when it came to the national security professionals, they actually just discounted advice from everyone, human or algorithm.
So,
And I thought,
it sounds like physicians.
So yeah, exactly. I often hear kind of anecdotes from the medical domain about kind of doctors ignoring some advice. And I thought, well, maybe they're expert enough to know maybe they should be discounting this advice. So I had to wait about a year in order to score the forecasts in terms of their accuracy to see, if the event had occurred or not. So like if Brexit actually happened or not. And it turns out that my lay participants, so people who are taking the studies on Amazon's Mechanical Turk, are actually making more accurate predictions than these national security professionals for these specific forecasts, at least, because they were willing to listen to algorithmic advice. So kind of depressing for the world, but I think it's kind of fascinating for research, and I'm really interested in figuring out why that happens.
So is the best advice at this point that the optimal decision making is going to come from some combination of human judgment and AI, and that the experts are just using human judgment?
Yeah, I am kind of surrounded by researchers who might even push that a little bit more. So there's some evidence that suggests that when people do have the chance to adjust an estimate from an algorithm, they're more likely to use it, but that they actually hurt their accuracy because in adjusting from what the algorithm says, they're adjusting away from the truth. So I do think it varies by context.
So on that point, I want to move to a question of judgment, decision making, and how accurate AIs can be. I don't know if you read Malcolm Gladwell's new book.
I haven't had time. I'm looking forward to
talking to strangers. So there's a section in the book where, and I think you've talked about some of these studies in your research about judges' judgment about recidivism and which inmate. So when a offender appears before a judge, you have to decide what bail should be. Should there be bail at all? And the norm has been historically the judges just look them up and down. They hear them talk. They make this is what they've been doing for 30 years, and they're going to make a judgment about who is likely to go out and commit crimes again and who is not. And they, and in these studies, they compared the outcomes for those judges versus just what would the algorithm predict. And it turns out that the judges way underperformed the algorithms and that it wasn't even close. And if you ask the judges, that they say, well, of course, I have to see their faces. I have to understand their demeanor. I want to look at their past. And yet these algorithms that know none of that, don't know any demeanor, don't know disposition, don't know language, don't know tone, don't know anything that they're presenting, and yet they're outperforming. So I want to know kind of what do you think about those studies, and how do we best use algorithms for those kind of things?
Yeah, so I love that work. There's another paper I've really admired for a long time out of the medical literature that kind of makes a similar comparison, but instead of judges to algorithms or statistical models, it compares pathologists trying to predict the severity of cancer to models, and the model blows the pathologist out of the water. And one of my kind of favorite pieces of this work is it shows why. So there in the medical field, the statistical model is actually picking up on cues that pathologists were never trained to look for. So that seems great. Now we can train our pathologists to use cues that this model has found. Even if we still don't like algorithms for whatever reason, you can still improve your decision making that way. And there's kind of a bunch of research going back to the 50s suggesting this in lots of different domains. So predicting bankruptcy of business firms, like I mentioned, severity of cancer. the group that I was working with on the Good Judgment project found that models were more accurate at predicting large-scale conflicts, pretty major geopolitical events relative to human experts. And so researchers have been finding this over and over again.
It doesn't bode well for human experts.
No, it doesn't. And I think if you ask human experts, well, what do you think of these models? It's not surprising that they'll say, no, I don't like it, because they know that they're threatened in terms of their job security then.
Which also includes management professors.
Agreed, yeah. So Mike Luca from HBS has a great HBR article on Harvard Business Review article on algorithms need managers too. So when it comes down to it, if you think of, well, how are we using these algorithms in the first place? You have to decide what the input is going to be in terms of being fed into the model in the first place. So a human does need to decide to do that.
Right, because so algorithms are only as good as the data that's coming into it. And we've seen a lot of this, especially on the HR side, in terms of discrimination for hiring. Right. I had the Tricia Griffith, the CEO of Progressive Progressive Insurance, on the podcast, and she was talking about all the efforts that they're going into using to de-bias their algorithms for insurance claims, and the challenge of guarding against racial issues and diversity issues. Because if all you do is feed into the algorithm raw data that is based on the history of Progressive Insurance and claims, it ends up being racist outcomes.
So no one likes to hear that. No organization likes to hear that. So it's brave of them to actually look at it.
And so and so I know you've looked at Amazon, but it's all the same issues. So what is the problem of these the biases within input data, and then what do you do about it?
So I think kind of the issue is whether or not organizations are open to detecting any flaws that they might want to fix. And so some companies just aren't open to that at all. But if you are going to be using input based on past decisions, your historical data, every company might have a different version of the bias. It could be ageist, sexist, racist. And those are obviously problems that we want to fix. I would argue that algorithms can help us detect them in the first place, because it aggregates our patterns for us and makes that bias more obvious. And so then you have a few decisions about how you would want to go in and fix that. Do you want to use algorithms for hiring and control for different demographic variables, actually have them in the model so that you can take them into account and make sure that there isn't bias in your hiring process? Or do you want to be training your human interviewers to be interacting with their interviewees a different way?
Wait, so I'm trying to understand, how would that actually look for hiring? If I'm running a hiring if I'm running a hiring algorithm, and so I'm going to put in GPA, and I'm going to put in so I'm going to have some code for past work experience, and I'll have a code for maybe how high up on the ladder at their past company that they've risen. What would I add in that would help de-bias the algorithm?
So before you can kind of de-bias it, you need to see the output and see what it's telling you. So for instance, Amazon found out that it was hiring mostly males at the expense of hiring females. And what they were able to learn from using the algorithm in the first place was that the algorithm was picking up on specific words in people's resumes. So they were confident, kind of laden words that it turns out were almost perfectly correlated or highly correlated with people's gender. So females weren't using these words, but males were. So they can see that the algorithm was using specific cues that end up correlating with demographics, and then go back in and either say, we don't want to use those cues, or potentially they can look at the breakdown of demographics and say, okay, well, we hired, this is kind of open for discussion and a little bit more outside of my field of expertise, but it sounds like some companies are thinking of, okay, well, we're going to actually look at people, the demographic pools, and if we haven't hired enough females, go back to that pool and interview folks. But that is kind of, I think, a really interesting discussion that a lot of companies are having right now.
Yeah, so I've come across that, right, where they have effectively a quota system where they say, well, we want our workforce to better reflect the mosaic of the United States, and so we're going to only interview, right? For our interviews, we're going to fly out 10 candidates, and 5 are going to need to be men, and 5 are going to need to be women. That seems like a really crude system.
Yeah, it's interesting though, because one of my colleagues here at Georgetown, Kathy Tinsley, has been doing work for many years on gender and gender inequality. And I just saw a recent talk of hers where she said, I didn't really see, I wasn't on board with quota systems like 5-10 years ago, but now I am. And I don't want to butcher her lovely work, but it's interesting to hear from her, a thought leader in the field, say, people have tried a lot of things, and actually quota systems are the systems that work, even though I think you're right. Sounds very crude.
So, but what I mean by that is that it seems like the last resort, right? You would want to hit it earlier, right? You'd want to adjust for gender and race early in the process, and then hope, and then the hope would be that the outcomes would be more balanced. I think the last resort would just be, well, we're going to hire 5 men and 5 women.
Yeah, I agree.
And so what does, I'm trying to get back to, I'm still trying to understand how you would control for, how you would actually get, in Amazon's cases, these words out of the system. I mean, maybe they can find 3 words that were angling towards a favorability towards men. But what about the other million variables that are going into an Amazon algorithm? I can only imagine how complex Amazon's hiring algorithms are.
Yeah, it seems like you would maybe go down a slippery slope of, once you redact these confident sounding words, what other information do you redact? So one thing to kind of get out of that loop is to use work sample tasks in interviews. So that's becoming more and more popular.
So what do you mean by that?
So if there's one thing that's predictive of future behavior and people's performance at work, it's definitely not interviews, that's for sure.
Yeah, we know
There's
that.
a ton of research that suggests that. But what is predictive is work sample tasks. So if they're, when I hire research assistants at the university, I often tell them, I know a lot of people haven't done a literature review. If they're students, why don't you give this a whirl? I'm interested in you trying to do a literature review before I ever hire them. And oftentimes I'll get students who come back to me and say, you're right, I've never done this before. Could you give me formatting, or do you have a template that I could use? And that just in itself is useful for me in hiring, because I know if they have questions on the job, they'll ask me.
Yeah.
So it becomes a little bit more, their skills are a little bit more tangible and highlighted in that work sample task in ways that could be really surprising, and it seems potentially like unrelated to the task.
You've done some other work on using algorithms to understand biases in an organization. How would you then, so we've talked about it in terms of hiring and some of the issues. How would you use it to understand biases?
Could you say a little bit more about that, what you're thinking of?
Like any of the Kahneman Tversky stuff? I don't know. Are people able to use AI to predict bias?
That's a great question, and I think a research question we should test.
Okay.
So I've been thinking of using algorithms to predict bias, mostly in the realm of interviewing and things like promotions, where you have someone's packet of past work and their resume. When it comes to things like overconfidence, so I've worked with, in grad school, I studied overconfidence with Don Moore at UC Berkeley, and I've been kind of obsessed with that topic ever since. People don't respond well when you tell them they're overconfident.
Yeah, sure.
I remember actually a little anecdote, not evidence-based, but Don was giving an exec ed talk to a bunch of bankers. And 3 days they were talking about overconfidence. And on the third day, someone finally raised their hand and they said, okay, enough about our clients and how they can show bias. Why don't we talk about how we make decisions? And the whole room just kind of went silent. And I think it's a great example just because it's pretty easy to see bias in other people's decisions, but we have these bias blind spots that great scholars like Max Bazerman have written about. I would love to think more about how algorithms can reveal biases, not just in our hiring decisions, but in our other kind of day-to-day organizational decisions. And I think that area is ripe for future research.
Do you see any role of the government stepping in to regulate algorithms? I mean, right now we are in the Wild West, and unless you break some overt discrimination based on sex or something else, then you're pretty much in the clear. So do you see government needing to step in?
I'm so glad you asked that. So I'd been kind of wondering that for a while, and it just so happened that when I moved from my postdoc to Georgetown, I was presenting some of my work at a conference in DC, and I was approached by someone at the Senate on the Committee on Commerce, Science, and Transportation, and they invited me to go in and talk with them because they were collecting information in preparation to create a bill on privacy that had some elements related to algorithmic bias. And the really exciting thing is, after I talked with them, they ended up getting back to me and giving me an update. So I think this was in December. They actually released a new privacy bill. So it's a nascent bill to combat algorithmic discrimination in one of the sections, but it's a really interesting bill where they say there's basically a call for companies to have audits of their algorithms and see kind of what the algorithms are producing in terms of decisions, which I think is exactly what we need.
And what kind of teeth would you put in that? I understand how you would audit it, but then what do you do with that information?
Yeah, so I think that's really the question. I think that's what everyone is trying to figure out. I also had questions like, well, who should be going in and auditing? Should be a third party, right? Like, there really aren't companies now that I know of who are auditing. I've had students in past classes. I had a great student, Michael, who had come up with the idea of, here are specific ways that we could audit algorithms. And I'm actually not aware of any companies that go in and do this for people. I think right now it really falls on the data scientists, the computer scientists who are working with the models now to kind of audit them as they go, which is actually a lot of responsibility. And it doesn't seem that it should really be the same team that created the algorithm to then go in and audit it, right? You might need someone with a pair of fresh eyes. If we can't see our bias blind spots, this is one reason why a third party should go in.
But one of the challenges of that is that even the team that makes algorithms, let's say Google's search algorithm, they don't understand the inputs and outputs. Mm-hmm. So these things are so immensely complex that it's why we get back to the example of Amazon identifying a few words. Well, it's like, well, great. But Google's algorithms or Amazon's algorithms are so complicated that there's actually no one person or even team that really understands it, except for whether it works or not. I mean, they're really good at identifying whether it works, but all the interaction effects that go on are difficult even for the coders to figure out, let alone somebody on the outside.
Oh, right, definitely. And Dan Goldstein is a researcher at Microsoft. He has some great data showing that people respond to algorithmic advice pretty favorably, regardless of how much information they have about it. So regardless of if it's a black box or they have a lot of information about what's going on in the system, which kind of makes it a little bit scarier, actually.
Well, that's amazing that you got called in for the privacy bills. Just wanted to get to one other thing. You said you have interest in finding collaborators. Do you want to just talk a bit about the kind of collaboration you're looking for?
Yeah, thank you so much. So I'm always interested in talking to people in academics or industry. I have been more and more, I've been getting approached by some folks in industry who are making decisions, and more they are incorporating algorithms into that decision-making process. So I'm always interested in talking with those people. In DC, it's been folks at the Senate and then people in national security. But I've also talked to folks who are making investment decisions and trying to figure out how will their clients or their own employees respond to algorithmic advice. And in science, the answer, as you know, is never so simple as this always happens.
Sure.
The answer is always, it depends. So I'm always interested in talking to folks who might have data that they are able to share to kind of look at those questions within their organization. So thanks for that. I appreciate it.
All right. Well, this has been a fascinating conversation. I've really enjoyed having you on, and this has been great.
Thanks so much. Thank you for having me. This has been really fun.
Thanks for listening to the podcast today. If you have any questions or comments, you can email me at jeffshatten1@gmail.com. You can tweet me at jeffshatten. If you like this podcast, press the subscribe button and make sure to rate it on iTunes so that other people can find it.